So again, today we're going to talk about volume of prisms and cylinders. Formulas are very similar, yet a little bit different. That's what makes this unit so difficult. There's so many different formulas. You've got to work hard at keeping up so that you don't confuse them all. Okay? And make sure if you struggle with formulas a little bit, that you get a formula sheet and write them all down on it and draw pictures and put examples and don't cheat yourself by that opportunity to have everything together in one place. Okay? Cavalieri's principle is pretty basic. It's saying that if two figures have the same base area and they have the same height, that they're going to have the same volume. They don't have to be the same shape. So we have two irregular shaped figures here. Something that kind of looks like a rectangular square type thing. And then we have some other squiggly looking thing. If this is the shape of the base and we knew that those areas were the same, they both were, say, 20 square centimeters, and we knew they had the same height, it wouldn't matter if they were right or if they were oblique. It wouldn't matter if they that they have different shaped bases. They'll have the same volume. What that means then is the formula for volume is pretty simple. It's base area times the height. It doesn't matter which shape the base is. We find the area of the base, we times it by the height, we'll have the formula for, or we'll have the volume of the figure. And so it's important again to keep in mind that the height is referring to the height of the prism or the cylinder. So you look at the overall figure, whatever it is, you determine what the height is of that figure, and that's what that H stands for. Oh. Sorry, my dot disappeared. It's not required to be there. Multiplication is implied between two letters, but still, I'd like to emphasize that base times height. Okay? Any questions on that? All right. Moving on then. Superman's lunchbox. Packs his lunch before he heads off to the Daily Planet. Pause while you copy that down, and we'll talk about it. So, what is Superman's lunchbox? Your phones are out, and I see you texting on them. I'm going to turn them into the office today. I'm really annoyed with that stuff. So tell me, what is Superman's lunchbox? What is it? It's a prism. Slash what?
Cylinder.
Slash cylinder. What do you mean by that?
Well, because the bottom, the rectangle slash bottom part is like a prism, and the top part is like a half of a cylinder.
Okay, so on top we have a half a cylinder, and on the bottom you're saying we have a prism. What kind of a prism?
Rectangle.
A rectangular prism. Okay, I totally agree with that. How tall is his lunchbox?
7.
Is that the whole thing or just the part up to the cylinder part?
7 is, usually the numbers are put in the middle of the sides, and so if that's in the middle, we're talking from here to here.
Oh.
And in something like this, if they intended to go further, they probably would put a line here and go like that. But they didn't do that. So, I should say I didn't do that. Intentionally didn't do that. So, how tall is his lunchbox? 7 plus x. Okay. How tall is x? That's why to you it's x, huh? It's dead to you. We can, if we look at this carefully, we can determine how tall that is. Jordan, you have any thoughts on why? What part of that cylinder do we know? The height, how tall is it?
It's 10 inches.
10 inches, so you're saying from here to here is 10 inches, and that's the height, meaning the cylinder's really laying on its side, right? Okay, what else do we know about that cylinder?
It's radius.
What is it? He told me you knew the radius.
No, I just know it's there.
It is there.
I don't know it. Not that good.
It is there, not directly drawn. What is directly drawn there? Not the radius, the D one.
Oh,
6
Oh,
inches,
The diameter is what?
6 inches.
Yeah, this is the same as this, so that's 6 inches. So what is that radius?
3.
That's correct. The radius is 3. So again, I ask you, how tall is that lunchbox?
10.
10 centimeters, or 10 inches, sorry. 10 inches, okay? So if we want to find the volume of Superman's lunchbox, we're going to have to find the volume of the rectangular prism. Would you agree? And we're going to add it to the half of the volume of the cylinder. Would you agree with that?
Yes.
Good, I'm glad you agree with me. So let's begin with the rectangular prism. Sorry. The volume of the rectangular prism. Let's begin with that. How do you find volume? Let's write the formula down. Go ahead.
V times base times height.
Base times height, like that?
No, the capital B.
Area.
So you didn't mean to say base, you meant to say
Capital B.
base area times height. Okay, good. So what shape is the base, Christy? What shape is the base?
Rectangle.
It is a rectangle. So if we tried to draw the imaginary lines in there, it might look something more like that, right? Looks like I drew a little high in there, but that's all right. Looks something like that. So, we have an agreement that says whenever we're finding our agreement was with surface area, but it's going to be the same with volume. When it's a rectangular prism, where do we agree the base is always at? Let's say louder, please. The side it's sitting on will be its base, right? That's correct. So in this case, we're saying this is the base of our rectangular prism. Okay? That's the base for a rectangular prism. So what shape is it? What did you tell me, Christy? It's a rectangle. So that green rectangle, if we pulled it out of there and ignored everything else, would look like this. And we would call this the base and this the height of our rectangle, wouldn't we? So how long is the base? 10. And how long is the height? 6. I think I heard a 7 or 2 in there. Remember, only looking at the green. The 7's not part of that green, is it? So this is the hard part. Ignoring all the other things when you go to find the individual parts you need. And right now you have to realize the base of this rectangular prism is this rectangle. And so if we redraw that rectangle up here, okay, it has a base and height also. And its base is 10 and its height is 6. And so the base area is going to equal 6 times 10, which is 60. Now, what did we say H stood for in this formula? The height of the prism. So now, just looking at the rectangular prism, not the whole lunchbox, but just the rectangular prism, how tall is it? 7. So So if we're just looking at this, okay, we're just looking at that, the height of that is 7. And so that's what goes out here. And what's 6 times 7? 42, and so 60 times 7 would be 420. What's my unit?
Inches
Square.
Inches cubed, because we're not talking area now, we're talking
Oh,
volume. Base area was inches squared, and the height is inches, and so then that gives us inches cubed. Okay? So volume is inches cubed. Now let's find the volume of the cylinder. What's the formula for volume of the cylinder?
base area times height.
Base area times height. What shape is the base?
A cylinder.
No, what shape is the base? You gonna say whatever he says? He's wrong. Don't repeat him.
The base is a circle.
The base is a circle. Is this cylinder sitting on its base?
Oh,
Or is it laying on its side?
On its side.
It's laying on its side. Remember, in a rectangular one, we'll agree it's always sitting on its base. But in any other cylinder, prism, whatever, you have to identify what the base is. And in this one, it's a circle. Right? So the base is a circle. What's the formula for area of a circle?
pi
Radius squared.
squared.
Pi r squared. So what's the radius?
3.
3. So we go pi times 3 squared times the height, which was, sorry, what's the height?
10.
10.
So it would be 90 pi.
That's right, it'd be 90 pi. And so then if we go back up here, whoops, inches cubed. If we go back up here, we found this to be 420 plus this, which is half of 90 pi. And so that gives me 420 plus 45 pi inches cubed. If they said in terms of pi, this is the answer. It looks strange, but if they said leave your answer in terms of pi, you have to leave it that way. 420 plus 45 pi. Because 420 and 45 pi aren't like terms, are they? This doesn't say 420 pi, it just says 420. So we can't mix those two together, so you leave it that way. If they said round to wherever, we'll say tenths, then the answer would be, and plug this in your calculator, what's 420 plus 45 pi?
561.4.
561.4 cubic inches, or inches cubed. Okay? That would be my answer for volume. Any questions on that? What shape is this? Triangular prism. That's correct. And if they did this, what would that mean? All sides are equal. That makes it what? Louder? Right. I meant what makes that, what does it make that triangle then? What's the special name for that triangle if all the sides are equal?
Equilateral.
Equilateral. Or we had an R word that we used for All polygons, if they had the same size. Regular, yeah. The angles and sides are all the same, they're called regular. So you could think of it that way also. Is this triangular prism sitting on its base?
No.
No, what shape is its base?
Triangle.
It's a triangle. Okay? Keep that in mind. If you want to find the volume of this, you're going to have to use the formula. Volume equals base area times height. What would the height, the h, represent in that case?
The,
Height of the prism,
The height of the prism, which in this picture would be what?
the long.
sideways long.
The length of it, wouldn't it?
Yeah.
If this is a tent, in other words, the height of this triangular prism would be represented by the length of the tent. If it was 5 feet long, okay, then Catherine might be happy with this tent, but Seth not so much. Okay? So the length of the tent is actually the height of the prism. And so how would I find the base area? She's saying a squared plus b squared equals c squared. Do we agree with that? Does that tell me area?
No, that's the Pythagorean theorem for right triangles.
Right, it's Pythagorean theorem for right triangles, which will help me find a missing side, won't it? And so there's two flaws. I'm not looking for a missing side, I'm looking for the area, right?
1/2
And the second is this is not a right triangle, is it? Is it?
It's fine.
What do you tell me the formula is?
1/2 base times height.
It's 1/2 base times height. Well, what's wrong with that? Well, say I know the side is 6. I still have a problem. What is it? I don't know the height, because in this formula, the base and height have to be, they have to be perpendicular to each other.
Yeah.
So if you say, well, that's 6, but these are all the same, so these are all 6s, I still don't know the height.
Well, you break it in half, and that would make the one side 3, the other side 6, and then you can use the Pythagorean theorem to find the third side.
I could, absolutely. Now she's starting to think correctly. But if we remember back, if all these sides were 4, then all these angles would have to be 60, wouldn't they?
Yes.
You can use trig.
And then we have this formula that used trig to find the height and plug it right into the formula. And remember, the formula was side, angle, side. In other words, pick two sides and the angle between them and plug them into this formula and you'll get the area. So the area of this triangle would be 1/2 4 times 4 times sine of 60. So what I'm getting at is if it's a right, I'm sorry, I misspoke. If it's an equilateral triangle, then the easiest way to find the area is to remember this formula. Otherwise, you have to do what Maddie was saying. You'd have to use trig or Pythagorean theorem or your knowledge of a 30, 60, 90 to find that unknown height. Okay? And if you think back, when we talked about this formula the first time, we actually showed briefly, very quickly, how this height was found by using sine. And so we can call that h. But we took this side, which is 2, and we said half of base, I'm sorry, we didn't either. Let me back up. They used trig. I was combining 30, 60, 90s with. But anyway, we used trig and we said this is opposite of 60. And so we said sine of 60 is equal to opposite over hypotenuse. So h is equal to 4 times sine 60. Well, that's where this came from. That 4 sine 60 is that height. Okay? And so if we plug this in our calculator, what do we get?
That one is 6.9.
6.9-ish?
Yes.
Okay, so that'd be my base area, and then I'd have to times it by the height of my prism, which I don't really have this prism drawn. The one I threw on the other side, remember I made those sides 6, not 4. And I just made those up to lead you into what was next on the slide. All right, any questions on this? All right, your assignment today is 1 through 19 all. You have quite a bit of time to work on it. I'm going to wander around and help you. Just try not to waste time, okay?